Okay, so I want to talk about today is the atom. And what we want to look at specifically is the idea of kind of how we came to our modern day model for the atom. So to kind of paraphrase Richard Feynman, he described atoms under the following way. So he said atoms, just to give us a general background, they're little particles. I know I'm not writing well enough to see, so let me write this a little bit bigger. He said that they're little particles that are constantly in motion. They're always in motion. They're always in motion. And his other thing about particles was that they're also either attracting each other, at slight distances, and then they repel at very close distances. So atoms are tiny little particles that are always in motion, and then they either attract or repel each other. Okay, so where did we originally come up with, when did we originally start thinking about the atom? Well, this goes all the way back to ancient Greece. And in ancient Greece, this guy called Democritus came up with the idea of this word called the atmos. And the atmos is the Greek for cannot be cut. So the idea is that this Greek guy, Democritus, comes up with this idea of the atom. And so this idea of the atom, or atmos, was the smallest thing that couldn't be cut. So as the story goes, Democritus he's standing there walking down the beach in ancient Greece, and he's looking at the sand and the little rocks in the sand. And he starts thinking about what would happen if I took that little rock and I kept cutting it in half every time. And what he realizes is he eventually would get down to something where he couldn't cut it in half anymore. And so that was what the atmos was. It was the thing that when you cut it down, you were at the fundamental unit, the fundamental thing. And so Democritus comes up with this idea of the atmos. And it kind of dies there for a long time. And it isn't until much later in the early 1800s that a guy by the name of Dalton revitalizes this idea of the atom. And so what Dalton does, Dalton reintroduces the atomic hypothesis, or the atomic idea. And Dalton basically, his idea is that all elements are made up of atoms. And that all the atoms of an element are the same. And he and his thought was that an atom is an indestructible thing. It was the base unit off of which everything else was built. So basically you have different atoms for different elements, and these little atoms are like these little indestructible spheres that go around. And so this kind of is revitalized and brought back up into the scientific realm, and he comes in around the early 1800s. And so once he puts this back into play, things in the next 100 years or so start to take motion, which is pretty impressive. And the next kind of step that the atomic idea comes across comes from a guy by the name of J.J. Dalton. And J.J. Dalton, not Dalton, J.J. Thomson, my bad, J.J. Thomson comes along and he discovers the electron. So Thomson, somewhere else in the mid to late 1800s, 1850 plus, he comes along and discovers the electron. And he discovers the electron because he has this um, tube, this tube kind of shaped thing, and what he does is he has this beam of electrons he can send out, and he has a plate here, and what happens is he shoots out his beam of electrons, and he has two plates here, two charged plates. And when he doesn't charge the plate, the electron beam goes straight through and hits here. But when he applies a charge to the plates, the electron beam is deflected. Actually, it's plus minus. And the electron beam is deflected towards the plus plate, and it lands down here. So what happens is, he says, hey, this beam here must be made of this thing called the electron. And when he discovers the electron, he says, and this little electron must come from inside the atoms. And so what he comes up with is what's called the plum pudding model, or the chocolate chip model. And the idea is that the atom itself, let's see if this will come up, the atom itself is made up of some big positive goo. And then embedded in the positive goo, he has the negative electrons. And the idea is that the charge of the positive goo balances the number of electrons, so you have the neutral atom, but each atom has these positive goo with the negative electrons embedded in it, kind of like chocolate chips. So Thomson comes up with the idea of the electron and develops this idea of the atom. After that, the next step that kind of came along was this guy named Millikan. Millikan does his oil drop experiment. And what Millikan comes along with and does is he does an oil drop experiment, and he actually comes up with the charge of the electron. So he discovers the charge of the electron. He's the one that quantifies it and comes up with a number for the charge of the electron. And it turns out to be 1.6 times 10 to the negative 19 coulombs, if you're keeping track at home. So after Thomson discovers there is an electron, Millikan comes along and comes up with the charge value. Now, what we're going to have to do is we're going to need to make a little more space on our board. So we're going to erase our friend Feynman's definition of the atom and Democritus, and we're going to come in to do the next step. And the next step in this puzzle came along with a guy named Rutherford. And what Rutherford does in the early 1900s, like around 1910, twiddle, 1909, 1910, Rutherford comes along, and Rutherford's going to discover the nucleus. So this is a big move forward. And so poor Dalton, you got to go need some space. So, Rutherford comes along, and what he does is he discovers the nucleus. And this is his famous experiment called the gold foil experiment. And here's how it kind of goes. So you can imagine if you're looking, this semicircle ring represents his detecting material. And here in the middle of the detecting material, he sets a sheet of gold foil. So this is this outer barrier. This is his detector. And this is the sheet in here is the gold foil. Okay. And what he has is he has a source over here. He has a source, and this source shoots charged particles. It shoots these alpha particles, which are heavy charged particles at the gold foil. Now, what were they expecting? Because Thomson had proposed his model over here, they were expecting, the particles to kind of go through like this, and they should have detections kind of in this region back here behind the gold foil. Because these charged particles from the source were big and heavy, and they would be like shooting, what they said is it'd be like shooting cannonballs at tissue paper. And so they'd expect their source charge to fly through move through the gold foil with no problem because it's some, thin gold foil. And these charged particles should just go through this squishy jelly of positive charge and arrive on the other side. Well, what really happens is they get stuff where the particles come in and these particles get deflected back this way and over here and up here and over here. They get deflected in multiple other directions. And this was such a shocking thing, they redo the entire experiment because they figured they must have done something wrong in the setup or in the detector. And so they rerun it and they get the same results again. And so this is one of those moments in science where when your data is telling you that something isn't what you think it is, you need to rethink what you're doing. And so Rutherford has to come along and he has to rethink Thomson's model. And so here's what Rutherford comes up with. Rutherford leads us to the next development of the model of the atom. And so what Rutherford says is the atom is this idea, and at the center of the atom, and I overdrew this, let's bring this down a hair. At the center of the atom is the nucleus. And the nucleus must be made up of this positive charges. And he says all the positive charges like a point at the center of the atom, and then the electrons are somewhere around outside of the nucleus. And so the idea is he has all these atoms, laying around with their little point nucleuses. So all the positive charge is like a point at the center of the atom. Now what happens? Well, now when you shoot your particles, sometimes they do go straight through and they hit the back of the detector. And sometimes they come in and they'll deflect in a glancing blow off one of the atoms, off one of the nucleuses. And sometimes they come in and hit a nucleus almost directly on and come almost straight back out. And so this idea of putting all the positive charges in some dense little core called the nucleus is the only thing that Rutherford can think of to explain the results he was seeing. And that's how Rutherford comes up with through his gold foiled experiment, Rutherford comes up with the nucleus for the atom. That all this charge is in the dead center of the atom, and the electrons are moving around outside the nucleus, and that helps explain his gold foil experiment. Now, it's not going to be until a little later, I think in the 1930s, 40s, somewhere in there, that a guy by the name of Chadwick will come along and be able to identify the neutron in the nucleus. But Rutherford's the one that comes up with first the idea that he says, no, the positive charge isn't some goo, it's this point mass in the middle of the atom. So this is Rutherford's big add. Rutherford adds the nucleus to us through his gold foil experiment. So the next step that comes along is by the guy by the name of Niels Bohr. And what Niels Bohr is going to do is the following. There was some other issues running alongside with this, and the other issues that are coming alongside are related to the spectrum that atoms are emitting, the visible spectrum of the light that's coming out of atoms. And so in order to help explain that, this guy by the name of Niels Bohr comes up with what's called the planetary model. So Niels Bohr comes up with the planetary model of the atom. And this is what the planetary model is. So we now know that we have some big positive charge, the positive charge is sitting in that point. And what he says is the following. To help explain these patterns that they're seeing, the light pattern that they're seeing, he's saying that now electrons, so we have these orbits, and the electrons have to be in these fixed orbital patterns. So electrons move in certain fixed orbits around. And the idea is that they move in fixed orbits, and when they move from one orbit to the other, the idea is that when they move in these from orbit to orbit, they either gain or release, a fixed amount of energy, a certain amount of energy. They gain or release a fixed amounts of energy. And so this was a big step in moving towards the current model of the atom. It's still a convenient way when you're explaining certain things in science to think about in terms of, oh, the electrons move in these fixed patterns around the nucleus, and it's because of these fixed patterns that they move up and down by these certain fixed values of energy. And it's a good basic model, but it's a good stepping stone towards the final one. And the final model that we're going to talk about is actually our current model, and it's called the electron cloud model of the atom. And so this brings into effect is the quantum model. The quantum model is also called the electron cloud. And the idea now is you have in the center, of course, you still have some nucleus. But what happens is, I can't draw this very well, but the idea is that the electron is involved in some cloud space. So the electron, this is supposed to be like some type of cloud around the nucleus. The electron can be somewhere in this three-dimensional cloud space around the nucleus. And then depending on its energy level, these clouds take different shapes and they change the space or the location that the electron can be in. It isn't fixed to some orbit. It isn't like stuck in some goo. The idea is the electron's moving around somewhere in this three-dimensional space around the atom, and it can be anywhere inside of that space at any given time. And so this brings us into the last chapter, and this quantum model was developed by a few people, more than one person. And the idea is that these electrons, they move in some regions of space dependent on that quantized energy that they have, kind of using the other model. Those energies are fixed, that they can move from different cloud space to cloud space regions, and the regions that they move into are different shapes based on those energies that they have. But this is where we are now. This is the quantum mechanical model of the atom, and it's also called the electron cloud. So we started with the ancient Greeks coming up with the idea of this atmos, which could not be cut or not be cut. And they thought about that because they said, well, you could start taking something and cutting it down. The idea of you can, no matter how thin you slice it, it's still bologna. But he was thinking about sand, not bologna. And that was kind of the idea of the original atoms. And then we moved forward, and it isn't until Dalton in the early 1800s brings back the idea of the atomic hypothesis or the atomic idea, and then he reinstates this idea that, well, all the elements that we know, they're made up of atoms, and any element, its atoms are all the same. And he says that this atom is the smallest thing, and you can't cut the atom anymore. So that's Dalton. Then after that, it's not too much later that Thomson comes up and discovers the electron using his deflection of the electron beam. And then Millikan comes along and does his oil drop experiment and discovers the charge of the electron. Then after that, we have Rutherford, who does his gold foil experiment and gives us the nucleus. Then we move a little forward, we get the planetary model with Bohr, and then we move into the full quantum model that describes the electrons moving in these cloud-spaced regions around the atom. So that's kind of our brief history and rundown of the atom. And of course, just to add one more layer onto that, of course we know now that the nucleus, the protons and the neutrons, are actually made of smaller things than that. So the proton and the neutron that make up the nucleus aren't even the smallest thing, but they're a good place for most people to stop and understand the atom. There's the proton and the neutron make up the nucleus, so this is our nucleus. This is made up of the proton and the neutron. And then the electron is up in its little cloud space. And those are the three main components of the atom: the proton, neutron, and electron.